Hello everyone, welcome to Maths IAC. Here's another A-level exam question. This is a quite common question that you get in A-level physics. This is to do with upthrust density. Please pause the video and give this a try. When you want to check the answer, continue the video. A solid sphere of radius 6 centimeters and density 850 is completely submerged in a liquid of density 1200 kilograms per cubic meter. The sphere is attached by a light inextensible string to the bottom of the container, holding it in equilibrium. So we can mark the tension here as capital T. Calculate the upthrust acting on the sphere. Now, the formula to calculate upthrust is U is equal to V rho G. V is the volume of the object, which is pretty straightforward. This is a sphere. So it's 4 over 3 pi times R is 6 times 10 to the power of negative 2 in meters cubed. So that's the V. Rho is the density of the fluid outside. So this is really important. This is one of the things where people go wrong. People sometimes substitute 850 when they actually should have done 1200. So it's always the density of the fluid. So in upthrust, 1200 multiplied by 9.81. So the answer here is 10.7 newtons. Part B. Calculate the weight of the sphere. So W is equal to mg. That's pretty straightforward. M is the mass of the sphere. Mass is density multiplied by volume. So density is 850. Volume of the sphere is 4 over 3 pi r cubed, like before. So that is M multiplied by 9.81. The weight here is 7.5 newtons. Calculate the tension in the string. Now let's think about the equilibrium. Now this object is in equilibrium, meaning the resultant force on it is 0. Now let's see the forces acting on it. We know there is an upthrust acting upwards. There is tension acting downwards. Also, there is weight. Those are the only three forces, and under the influence of those three, this is in equilibrium. So for part C, we know, considering equilibrium, the upward force U is equal to weight mg plus T. So the tension in the string is U minus mg. We already worked out U in the first part, 10.7. Take away part B, we worked out the weight of the sphere, which is 7.5. So the tension in the spring here is 3.2 newtons. Part D. If the string is cut, describe and explain the motion of the sphere and calculates its initial acceleration. Now, let's see what happens. If you remove the string here, like that, now there is no more string. So, the only two forces acting on it are U and mg. But you can clearly see the size of U is greater than that of mg, which means there's a resultant force acting upwards. So when there's a resultant force acting upwards, obviously it will accelerate upwards. The question says don't worry about the viscous resistance. So let's write the equation F is equal to ma in the upward direction. So U minus mg is equal to ma. Now U is 10.7, take away 7.5 divided by m is a. We know The weight is 7.5 because remember, W is equal to mg. So 7.5 is equal to m times 9.81. M is 7.5 divided by 9.81. So here the acceleration is about 4.18 something. So let's call it 4.2 meters per second squared. Let's write the explanation of this. So here's what you can write. When the string is cut, there are only two forces on the sphere. Weight is acting downwards, upthrust is acting upwards. Upthrust is bigger than weight, so this object is not in equilibrium anymore. It was before when there was a string, but now it is not. So the resultant force is now upwards. When the resultant force is upwards, it will accelerate in the direction of the resultant force according to Newton's second law of motion.